Hello viewers, we have an interesting question on electrolysis, electrolytic reactions, and it goes as follows. Explain the effect of concentration on the anion that is preferentially discharged in the electrolysis of brine. So the first point of contact for you as a candidate is, what is brine? Because if you don't know what brine is, you'll be lost. Brine is simply concentrated sodium chloride solution. Okay. All right. So we'll go straight. And for the sake of those that are having issues with electrolysis, please do follow my channels. We'll discuss electrolysis later in details. It's because it's quite an interesting topic. So, brine being concentrated sodium chloride solution. Okay, yes, it's a solution. That's why I'm putting the state symbol aqueous. And I must tell you, whenever we have aqueous solution, it means water is present, H2O. Okay, so water is a solvent, so it is present. So based on our ionic theory, if sodium chloride solution ionizes, we'll have sodium ion in solution and chloride ion also in solution. Then from the solvent, water will also ionize to give us hydrogen ion in solution and hydroxide ions also in the solution. The aqueous means in solution, okay? In solution where water is a solvent. Now, I want to lay emphasis on something. During electrolysis or electrolytic reactions in this case, ions migrate to their poles of opposite polarity. What does that mean? The negative ions will move to the positive electrode, and all the positive ions will move to the negative electrode. And in an electrolytic cell, the positive electrode is the anode, while the negative electrode is the cathode. So for that reason, I use this style of crossing it. Okay, so here we have the anode, which is the positive electrode. Here we have the cathode, which is the negative electrode. So at the anode, we'll be having chloride and hydroxide ions. And this is where the interest of our question lies. So here they said, explain the effect of concentration on the anion that is preferentially discharged in the electrolysis of brine. Okay. Now, out of these two competing ions, chloride and hydroxide, there are factors that affect the preferential or selective discharge of ions during electrolysis. One of them happens to be concentration of ions in the electrolyte. We also have the relative position of ions in electrochemical series. We also have nature of electrodes used, but this question is basically looking at what? Concentration of ions in the electrolyte. So out of these two, the factor here says that we would consider the concentrated ion coming from the electrolyte if and only if the relative position of the two competing ions are far. When I mean far, if they are up to 5 ions apart on the ECS, that's electrochemical series, then we would ignore the effect of concentration. But if they are close, if they are 5 ions further away from each, less than 5 ions further away from each other, then we'll consider the effect of concentration. So for that reason, we'll look at the electrochemical series for anions. I usually use a mnemonic. So my mnemonic is Florence, so Nigeria could buy Indian oil. So you see, this is the order. This is the first, this is the last in the order of preferential discharge. This is the order of preferential discharge. It goes this way. So if I consider the position, this is hydroxide ion, this is chloride. So let me see how many ions they are apart. 1, 2. Just 2 ions apart. Okay, I may just say 3 if I include chlorine. So, and if there are just 3 ions or 2 ions apart, as the case may be, I tell you, they are close to each other. So since they are close, we must consider the effect of what? concentration. So I'll be rubbing this off. So considering the effect of concentration, which out of these two is coming from the concentrated electrolyte? Is obviously chloride ion. So because of this, chloride ion will be discharged in preference to the hydroxide ion, since it is coming from the concentrated electrolyte. So remember, the type of redox reaction that occurs at the anode is what? Oxidation, which is loss of electrons. So chloride ion in solution will be discharged to give us chlorine gas with the loss of electrons. So let's balance the equation. Chlorine is 2. I'll put 2 here. Because I have -2 here, I'll also put 2 in front of the electron. So the equation is balanced. Okay. So simply put, on your explanation, chloride ion is discharged in preference to hydroxide ion because the relative positions of chloride ion and hydroxide are close. So for that reason, chloride, being the concentrated ion, is discharged. It is this simple. Thank you for watching. Remember to like, share, and subscribe to our channel.